given the range of a logarithmic function. Now, y'all, the range is just the set of all outputs. It's a set. And the domain is the set of all inputs. And that's what we're supposed to find is the domain of f of x. And f of x is given to be a logarithmic function with a base that's greater than 1, which turns out to be important. Now, just to be clear on the domain and range, let's consider the function x squared, something simple that we all know the shape of. And we'll go ahead and specify that the domain is the interval of numbers from 3 to 4, y'all. And this literally means all the numbers greater than or equal to 3 and less than or equal to 4. This is called the closed interval. So now, the image of this function, this would be mapped to, and this is dependent on the squaring function being positive for positive x, or being increasing for positive x. So this is 9 to 16. Our function, you can graph it and see what it looks like. Between 3 and 4, you'd be passing through the points. We'll go ahead and do just a half-assed picture of this. Let's say 3 is here, 3 is here, and 4 is here. Yeah, it's typically, this is never going to be scaled properly, but you would have the point 9 right here. And let me just label this 9 just to cut down on the amount of writing I have to do. That's because 3 squared is 9, and then 16 would be, I got a little more room up here, right? We'll say 16 is up here somewhere. And again, nowhere near being to scale, but so that point right there, okay? So you see you have that much of the parabola, okay? It gets, in other words, this is the domain. You can think of it as the preimage, and this is the image if you've ever sat through a topology class. That's some of the language they use. Okay, but anyway, we're given this information for the logarithm function. We're given the output as for the interval minus 16 to minus 4. Okay, now y'all, the logarithm function is an increasing function provided the base is bigger than 1. It would be decreasing for any base between 0 and 1. I won't get into all of that, but what's important is that since, let me just write this, the fourth root of 3 is clearly greater than 1, since the fourth root of 1 is 1, right? So this is greater than 1. That means this function's increasing, which makes this problem kind of straightforward, actually, okay? Just like 3 gets mapped to 9 right here and 4 gets mapped to 16, we're going to have this relationship right here. The exponential function corresponding to this logarithmic function is the fourth root of 3 raised to the minus 16th equal to a. And so, y'all, what we're actually looking for here, we're trying to look for this interval of numbers. Okay, this interval of numbers, which will include a, terminate with b, will be the domain. Okay, equals domain. And again, it's important to know that this is a set of numbers. It's not just a and b, it's all the numbers that include a and b and are between a and b. Okay, so this is going to be the domain, which is what we're trying to find for this problem. Okay. Now, let's see, what does this mean down here? Let's keep going. This would mean 1, remember laws of exponents, so this is going to mean 1 over, and y'all, I'll go ahead and switch conveniently to rational exponents. So 3 to the 1/4 raised to the 16th power, and I'll envelop that in parentheses. Okay. Okay, y'all, this just is very straightforward on the exponent, so this would be 1 over 3 to the 4th, right? You know, again, conceptually this is true, and also just multiplying the exponents, it's true, but it lines up with what you would expect if you, from the fourth root of the square root of 3, if you raise it to the fourth root of 3, if you raise it to the 4th power, is 3. So this is 1 over 81 for our a. And in a similar fashion over here, you'll get 1 over 3. This is A, y'all, sorry. In a similar fashion, you'll get 3 is equal to 1 over 3, 1 over 3 is equal to B. There you have it. Slightly more complicated function than x squared. You have to be familiar with the relationship between the exponential statement. Every logarithmic statement has a corresponding exponential statement, okay? Which were these two statements right here. So y'all, the answer to the problem is, and notice the smallest number has to be on the left in this notation. So it's 1 over 81. Okay. And then this would be the preimage, I think, or something, or yeah, whatever. They had big words for this in topology. Okay. And so the image of this set would be minus 16 to minus 4. Okay, if you want to think of it like that. The image of this set of numbers under this function would be the interval minus 16 to minus 4. But we found the answer to the question, folks, right here. So this is it. All right, y'all. That's it.